2015 AP Micro FRQ number 3, and we need to, let me get my pen to work here. All right, calculate the total producer surplus at the market equilibrium price and quantity. So here's our market equilibrium price and the quantity. We know this is all consumer surplus up here. This is all producer surplus. They're looking for producer surplus. So looks like our height is 20. Our base is 20. So height times base divided by 2, or 1/2 base times height, whatever you use for a triangle. Looks like that's 400 divided by 2, so 200. Show your work. If the government imposes a price ceiling, or price floor at $16. Sorry, that's the trash truck. Let's say we draw it in at 16, 12, 14, 16. But what do we know about price floors? The way we say it, our mantra is floors are high and ceilings are low, right? Floors are high, ceilings are low. This floor we've drawn in below the equilibrium. It is not high, it is low, so therefore it is non-effective, and that's how we would explain it. It's non-effective or it's non-binding. Non-effective or non-binding. It will do nothing because it is below the equilibrium. All right, let's get rid of those. And let's say that instead the government imposes a price ceiling at 12. This is our price ceiling. We know ceilings are low. This is below the equilibrium, so it must be binding or effective. At this price ceiling, our quantity demanded would be 24, and the quantity supplied would be 12. So recognize that if your quantity demand is greater than your quantity supplied, obviously you have a shortage. And that's exactly how we would explain it. Quantity demand is greater than quantity supplied. All right. This next one is tricky if you haven't seen one that does this before. It's just the understanding that if the quantity was to be controlled at 10 units, that implies that all of this area becomes our deadweight loss, because at 10 units we've had a loss of quantity. We can see that we've lost that, so therefore that represents what deadweight loss is. I'm going to be quiet for a second until the stupid truck leaves. All right, so we can see our height. Looks like it's between 40 and 10, so our height is 30, and it looks like our base goes from 10 to 20, so our base is 10. So if we're looking for that area of that triangle, just 30 times 10 divided by 2, which is going to give us 150. I think that's right. Now we have to calculate PED values, right? The price falls from 20 to 12. Now, everybody seems to do the same thing when they're working on these. Here's our price at 20, our quantity demand. Here's our price at 12. Now recognize that the formula for PED is obviously a percentage change in quantity demand over a percentage change in price. But it is quantity demand, right? Here what tends to happen is people come across and they hit that supply curve and they think they need to go down, or they come across and they hit right here and they think they need to go down. None of that makes any sense. Quantity demand. At this price, the quantity demanded is 24. So we can do this a couple ways. If you have a big brain, you can recognize that you could figure out very quickly, oops, I didn't want to get rid of that. We could recognize what the percentage change. Let's say the price, or P1, was 20, and then P2, we went down to 12. So that would be 8 of 20, right? Which would be 4 of 10, which would be 2 of 5. I'm not a fraction guy, so this stuff doesn't help me very much. Obviously, I could do the math to figure it out, right? That is our price. But we need also quantity demand. It looks like our quantity demand when the price fell went from 20 to 24. So it looks like our QD1 was 20, and then our QD2, let's get rid of that because that's confusing. Our QD1 was 20, and I think our QD2 was 24. So it looks like 4 of 20. 4 of 20 would be obviously 2 of 10, or 1 of 5. This is obviously 20%. 2 of 5 would be, what, 40%? But that's the price. Be careful. That's the quantity demand. Flip it around. Tricky, tricky, right? You got to make sure you're doing it in the right way. 20% over the 40% would have given us 0.05 or 5%, which obviously would have been inelastic. You could also do this with the formula. I would be not willing to do this because I'm worried about. I mean, you can use the same formula for QD2 minus QD1 divided by QD1. I mean, it's the same thing, but for some reason, taking it slow like this, I tend to make less mistakes. P1, obviously QD2 was 24 minus 20, which is 4, divided by 20, which is what we did here, right? That's our quantity demand, 1 out of 10. 2 out of 10. Yeah, 2 out of 10, 20%. Nicely done. And then P2 is, 12 minus 20. Remember, it's absolute value for PED, so we're not worried about a negative number. 12 minus 20 is 8 over 20, which is 4 over 10, which is 40%, right? So 20 over 40 again. We also could check ourselves if we needed to, just to do a total revenue test, right? We can see that the price went from 20 down to 12. The quantities went from 20 to 24. So that's 400, 12 times 24. Oh my goodness, I can't do that in my head. 2 times 4 is 8, 2 times 2 is 4, put your 0, 1 times 4, 1 times 2 is 2, 8, 8, 2, 288. So what we recognize is that when the price went down, total revenue went down. If we draw our little graph down here to make sure we understand, here's our total revenue curve. If you don't get this or don't understand it, and that makes perfect sense to you, just do it. But I would always check myself with a total revenue test, just because with these numbers, it's not that difficult to do. This is unit elastic at the top of your total revenue curve. We're going to know that all of that demand is inelastic. All of this is elastic. Obviously, if our price goes down and total revenue goes down, we must be in the inelastic section of our curve. So we know it's inelastic here. And we've checked it with a total revenue test. Obviously, if we had lowered our price and we were in the elastic section, our total revenue would have gone up. So we can't be in the elastic section, only in the inelastic section. So we did it a couple different ways, and we got the same inelastic answer. All right, that was probably a little more pedantic than we needed to be, but fun to mess with the numbers. All right, guys, take care, be safe.